Hi everyone, so this is going to be the first of a couple of videos that are going to help you to re-look at factoring. So the first one here is common factoring. This one is where we are simply taking out the greatest common factor. So we're taking out the GCF from these particular examples. So if we're looking at the first one, we have 2x plus 5. What we want to do is figure out what are the common factors between both of these numbers. So we can do a factor tree to figure it out if we can't see it immediately about what is included. So I'm just going quickly through this. If we decompose or factor 2, we're going to see that it's only 2 and 1. 2 is a prime number, so the only way we can get 2 being multiplied is by 1. We're looking at 10. What we're going to see here is that we've got 10 and 1, 10 breaks down into 2 and 5, and 2 and 5 are again prime numbers, so we can't go any further. But if we look at it here, you can see that there is 2 and 2. So that means the greatest common factor that they have together, they share, is 2. So we're going to pull 2 out from both items, both numbers. When we do that, we want to make sure that we put the 2 out in front of the brackets and we divide it out. So 2x divided by 2 gives us x, because the 2's cancel each other out. And then we're going to add 10 divided by 2, which is 5. And that's how we factor out this particular number and bring out the largest common factor. So this 2 right here is our GCF that we have pulled out from this particular equation. Looking at another example, we have here just variables. We can see that we have an x cubed minus a 6x. Now, there's no constant other than 1 in front of the x cubed. So we can't do anything with our constants. But what we do notice that they share is an x. This one has 3 x's multiplying each other, and this one has 1 x. So what we can do for this one is simply remove an x. So how we do that again is we're going to divide each term by the x. We're going to put that GCF in front. So x cubed divided by x gives us x. So basically what we're doing here is dividing out one of the x's. So what can be looked at? We showed this kind of in class. Okay, I'm not going to do it as an x. We're going to use a 0, little dot here, to represent multiplication. And we're dividing it by an x on the bottom. These two x's, so this x and this x, so this guy and this guy cancel each other out, and we're just left with 2 x's on top. X times x is x squared. So get x squared here. Again, we look at the next term. We are subtracting 6x divided by x. These two x's are going to cancel each other out and leave us with a 1. But since negative 6 times by 1 gives us negative 6, we don't need to write negative 6 times by 1. We can just write straight up negative 6. And that is factoring out, taking that common factor, meaning they have these in common, out from this example. Now looking at our last example, we not only have variables this time in front, variables here, we also have constants. So it's important for us to know the largest common factor that all 3 of these numbers have. You guys can, if you see it, start off with just pulling it right out if you can see exactly what they all have in common. But if you're still having trouble with that, we can always make sure to do our factor charts. We break 8 down, 2 and 4, 2 and 2. This is our breaking down for 8. We're going to now do the same thing for 16. Break it down, 1, 16. Another factor is 2 and 8, 2 and 4, 2 and 2. Okay, and we're going to look again at 24. Same thing we're going to do. 1, and 24, 2, 12, 2, and 6, 2, and 2. Now what you guys are going to say here is that, oh, well, this one has 8, this one has 8, but this one doesn't have 8. Technically it does. I'm not sure if you guys noticed this when we were doing it in class. If you multiply these together, this gives you 8 times by 2, 3. I wrote something down there wrong. There we go. Let's fix that. That should be a 3. 8 times by 3. So these multiplied by each other is also what you would be multiplying by this number here in order to find it. So we do have 8. So you can notice that all 3 of these have a common factor of 8, which means the greatest common factor for these polynomials here, for these constants in front, is 8. So we can start off by getting these divided by 8. But that's not all we can pull out from these different terms. We can see here we have a m to the power of 4, an n to the power of 2, and an m. So this m to the power of 4 is 4 m's times in each other. This one's 2, this one's 1. We can't take more than what exists. So the smallest one that we have is m, just plain m to the power of 1. So we can at least take out an m from each of these variables. So now that we have it set up, we can actually go about pulling out the greatest common factor, which we have determined is this 8m. So we're going to put that in front of the bracket. So 8m to the power of 4 divided by 8m. The 8's cancel each other out, so we're left with 1. There's m to the power of 4 divided by m. Now remember, if you looked up here, we showed how it's just multiplying it out. We did the same thing with this one. We would have 4 m's next to each other multiplying out on top, and then on the bottom we have 1m. So that 1m would cancel out one of the top ones, which would leave us with 3m. M to the power of 3, my apologies. N to the power of 3. Okay, let's look at the next one. 16 divided by 8, okay, that leaves us with 2. Now looking at the m, we have m to the power of 2, so that's m times m divided by m. One of those m's will cancel each other out, and we have 1m left. Next one, 24 divided by 8, that gives us 3. Now these two m's, so the m on top and the m on the bottom, those are going to cancel each other out, leaving us with 1. But we know 1 times by 3 is just 3, so we can leave it as that. So our final result is 8m bracket m to the power of 3 minus 2m plus 3. Ways that we can check to make sure that we have done this properly is simply multiplying it out and seeing if we get the same answer. So because this one was a little bit more complicated, let's double check our answer. So if we're going to check our answer, we're going to write this out, make sure that we did it right. We're going to redistribute in this 8m. You can check your answers by doing this at the end if you're not quite sure that you did it properly. So if we were doing this, let's write it out like we would have done it the long way for distribution. We had 8m times by m to the 3 minus, well, plus 8m times by negative 2m plus 8m times by 3. Multiplying this out, so we have 8m times by m to the power of 3. We get 8m to the power of 4. Then we look at our next term, plus 8m times negative 2m. Okay, well that's going to be negative 16m squared, because m times m gives us 2m's, m squared. And last but not least, we're going to go look at 8m times 3. That's going to be 24m. By the end, when you test this out, this answer at the bottom here should be the same as the top one. And if we look, yep, they're the same. That means this expression is correct. This is the proper factoring of this number. Hopefully this helps. Take back, look over at how you can do common factoring. And the next video that will be posted is about simple trinomial factoring, so that product sum.